Yeah, we'll see, because this is the only chance for making a video. I actually even said first hour um, that I had to make a video and then I forgot. So gotta risk it here. I don't have a video online. Hey, by the way, sine of alpha plus beta. What if I made both of those angles equal and just said it was alpha plus, or sorry, theta plus theta? I know that sine of isn't. Sorry, I'm having struggles with my words. What's theta plus theta? What's theta plus theta? 2 theta, but let's exercise the little rule. And the little rule says sine first angle, cosine of second angle. Well, they're the same angle. And then sine stays the same. And then it's sine of second angle. Well, that's still theta. Cosine of first angle. That's still theta. Wouldn't you agree that you see two of these sitting next to each other, right? So there's a way of like deriving these. What is going on with cosine 2 theta? Well, let's go ahead and look at our formula from yesterday. Reason sum is because I make both of these angles equal and just play the game. So what's cosine? It's cosine minus sine. What's cosine times cosine? Say it. There you go. Cosine squared. So that's how I get this one. Why on earth do we have two other formulas for cosine 2 theta? Does anyone have any ideas? Starts with a P, Py, Pythagorean theorem. So I could take this cosine squared minus sine squared. I could take that sine squared and plug in a 1 minus cosine squared in its place. And then I'd end up getting this one. This one's very easy to see. I could take this one and take cosine squared and replace 1 minus sine squared for cosine squared and then leave that minus sine squared alone. Everyone can see how that creates that one. I don't feel like writing tangent, but isn't the tan sum rule tan plus tan? What's tan theta plus tan theta? Look at the top. 2 tan theta. Then it's 1 minus tan tan. What's tan tan? Tan what? So it's easy to kind of derive that where that comes from. So yes, you have another on your plate, another set of formulas to memorize. Just for giggles, they set this up, and just for giggles, we're going to go through the process to prove that these identities work. So what's 90 if you read those directions? 2 times what? It's easy. What's 240? 2 times 120. Now I know all of these angles, we could figure out the trig. So we would never use a double angle formula to actually evaluate them in exact form. But we're gonna go through like doing this 2 different ways and see that we get the same answer. Just for giggles. It's still not going to be a long set of notes. I'll be done pretty quick here. So, all right. So, yeah, you can read those directions. And I just told you what the drill was. First of all, what is the sine of 90? What's the sine of 90? What's the answer to that? Straight up, okay, 0, comma 1. The answer is 1. But just for giggles, that's my brain, not my pen. Employ the double angle formula and see if you get the same answer, and then that means there should be merit to it. Okay, so what's the sine of 2 times 45? 2 sine 45 cosine 45. Hey everyone, what's the sine and cosine of 45? What? We don't know? Root 2 over 2. Okay, root 2 times root 2 is 2. 2 times 2 is 4. What's 2 times 2 over 4, or what's half of 2? 1. So this is just proving I did it a different way. I got the same answer. This must have something to it. All right. Let's play again with cosine rule and do the cosine 2 times 120. Do I have to stamp? We didn't do anything yesterday, did we? Nice. Except for quizzes. We did something. Okay. Hey, I like I like this rule. Since I have three possibilities, I like this one the best. I don't know why, but I that's the one I'm going to use because I have choices and I'm going to choose this. And then remember -1. What does this mean? This means this. I should use brackets squared. So what you do is you take the cosine of 120, get that answer, and then square it. That's what cosine squared of 120 means. We've done that before. It hasn't been in a while, so that's why I wanted to show that one more time. Okay, and then what's 120? And we had to switch gears on, and I saw somebody, I see her right now, writing their unit circle with degrees because that's like kind of newer. So what's 120? How far is that away from 180? It's a 60, that's it. So it's an over 3. Sorry, I almost said 6. So what's cosine of an over 3? What's cosine of an over 3? Oh, and by the way, I forgot to do this. This is a 60 in quadrant 3. So what's the cosine of a 60 in quadrant 3? What's the answer to that? -1/2. Okay, so I'm supposed to be getting -1/2 when I'm done with this. Are you okay over there, James? You need a pillow up against that wall? All right. So 2 times 1/2 negative squared -1. But it doesn't matter. If you even accidentally didn't put the negative in there, squared is still a positive. You do get 1/4 times 2 minus, oh, let's just make it 4/4 just to help us out with our grade school. All right, what's 2/4 minus 4/4? What's 2/4 minus 4/4? -2/4, which will reduce and make that -1/2, and that's proof. I should reduce that 2/4. I don't feel like rewriting. All right, and then, oh boy. First of all, what's the tan of an over 3? Is it √3 or is it √3/3? Which one is it? It's √3. Tan of an over 3 is √3. It rolls right off the tongue. All right? And then what's tan in quadrant 4? Negative. Okay, but then this is tan of 2. Huh? Huh? I wasn't finished. Everyone just relax. All right, sorry. I said 3. Sometimes the brain just glitches. All right, 2 times 5 pi over 6. And then, oh no, we're going to go through this because this is good. This is the hardest part of the tangent rule anyway, so we'll play the game. This will be part of your lesson here. How do I handle these radicals in a fraction, within a fraction, blah, blah, blah. Okay, so we know the rule. It's 2 tan 5 pi over 6. Okay, so 5 pi over 6 is the argument of this thing, and then it's 1 minus, I'm going to write it the right way, not the right way, the way that we have to think about it. Well, now I'll write it like this, and then we'll replace it. Here's the problem. The tan of 5 pi, what's tan of 5 pi over, what's tan of over 6? That must be what? √3/3. But you know what I did in the other hour? I did it as 1/√3. That's where it comes from. And you got to be able to go back and forth and be able to handle that. It's going to help our simplification process. Okay? And then this is over. Now I'll write it the right way or the better way. I'll write this as this being squared, and it is -1/√3 squared in there as well. Okay, so I'll zoom in on that real quick. So instead of √3/3, which creates more of a rationalization issue, write it as 1/√3, and you should not be confused about that. All right, and then how do I multiply 2 times that? And if you need more help on this, go back to grade school. Yes, we're going to be passive aggressive. Are you okay back there? Your group's going to faint. That was a huge yawn. You just stole all their oxygen. And then what's 1 squared? 1, what's √3 squared? Isn't that easier? Okay, so that's 1/3 on the bottom. So it's, you know what, oh, you want to get nuts? Let's get nuts. Why did he do that? All right. I do get on him for having fractional, what do we call it? Fractional what? Fractionally what? Challenge students. Okay, it kills them. All right, and then I'm going to go down here. -2/√3 over 2 over 3, right? Okay, and actually I don't have to simplify too hard here. Basically, I could just do the divide is multiply flip rule because I don't have anything really complicated here. Okay, so the 2's cancel. Yikes. So I have negative 3 over root 3. Yikes. Well, when I multiply top and bottom by root 3 by rationalizing, then this becomes 3 root 3 over. Don't lose the negative. I was talking to myself. And then root 3 times root 3 is 3. These cancel. And then lo and behold, I do have what I was supposed to get, negative root 3. So that was kind of a good process, though, to help you on simplifying. I told you, I know this is trig and using identities, but then we're going to count you for more points about how to rationalize a denominator. So that came back, and we got to know what we're doing. Okay, you should like these. Read the directions here. Write each expression as a multiple of a single trig function using double identities. This is a multiple trig function. But which one is this? The sine or the cosine? Come on. Sine or cosine? Sine. It's the sine to theta rule, where the argument is actually 3a. So this ends up being sine 6a. And then that's it. Okay? So I followed the rules. I wrote it as a single trig function. I followed the rules. Next, which one is this, sine or cosine? Come on. Or tangent. What a dumb question, right? That's a cosine one. And it's the I think it was the third one I listed, I think. So this is the cosine 2 theta rule. By the way, we do like this. 2 times pi over 12 is pi over 6. I guess for the directions, that's the answer. But what is the cosine of pi over 6? Just for giggles. Root 3 over 2. We often ask you to do that. Like in a multiple choice question, we might have those listed as the answers. Root 2 over 2, 1/2, root 3 over 2. And then you gotta, oh, okay. After I do the first step, it turns out to be something I can evaluate. All right, we're almost there. Ain't no thing. Anyone? Chicken wingers. Oh man, I guess we have a lot to go. Oy. Okay, you know what though? I can knock all these out with the same triangle. So that's what we got going on here. And why is that? This is 2 sine theta, cosine theta. And this is what they gave me. I actually have one of my ratios I need. So I can really right now insert that in there. And actually, to be honest, I could do this one right now because there is one of the formulas that only has sine in it, sine of theta. It's the 1 minus 2 sine squared theta. But I can't do the tangent one. I need tangent. So what do I have to do? What does that mean, everyone? Make anyone? Anyone? Drawing or triangle, same thing, both correct. And then there we go again, we're in degrees. So I was talking about that student that I saw did their unit circle real quick with degrees just to make sure. What quadrant is that? 4. So it's not an inverse question. They could have said quadrant 3 as well. So you got to read the directions. That dictates what the x is, which means it's positive. I didn't do those words or sounds. Y over r. So r is 3. Negative 2 root 2, and then I'm not writing the Pythagorean theorem anymore. I quit. 2 squared is 4. A negative squared is a positive. That's why I ignore it. 2 squared is 4. Root 2 squared is 2. 2 times 4 is 8. 3 squared is 9. What's 9 minus 8? What's the square root of 1? That's real easy. And the fact that we're in quadrant 4 from those directions means that 1 is positive. So cosine is 1/3. Nice. And then I'll zoom in on this and finish this off. Well, it ain't no thing. Chicken wings. 2 times negative 2 is negative 4 root 2. And then 3 times 3 is 9. No, you do not multiply the denominator by 2 as well. Go back to grade school. All right, now I'm open to use whatever I want, but I'll stick with that thought process I had before. Hey, in case I got the wrong x value, I would just avoid it and I would do this one. I would say the 1 minus 2 sine squared theta because I have it already. What if I made a mistake on cosine? I'm just saying. But I'm just saying you also have, multiple ways you could do the cosine one. Okay, we're going to write this correct. This is negative. Actually, this is kind of silly because I made my life. I know what I did. I changed my decision because I used the cosine one because isn't it easier to square 1/3, right? But I'll stick with my decision. Okay, because I already did this. What's 2 squared? What's root 2 squared? What's 2 times 4? So this is just 8/9 in here. And then I got to proceed on. That becomes 16/9. So I'm going to write 9/9 for 1 minus 2 times 8 is 16/9. 9 minus 16 is negative 7/9. You know what I did? This is what I did for tan 2 theta. And I think I'm going to check my notes when I do this. I already know what tan 2 theta is. What's tan? Tan is what letter over what letter? Y over X. So guess what tan 2 theta is? It is negative 4 root 2, over what? Negative 7. He's the only one that said it. X, Y of this angle measure, right? Got it? And let me see in the other notes if I did exactly that or if I went through and did the work after that. That's what I did. I did the same thing in the other hour. Because thinking, smarts. But maybe what might be smart is knowing that, then going through the process of tangent just to check all your work, make sure. But I'm not because of time. I think we have a tangent later that gets a little bit more rough. Then you have these. Now all you got to do on this is, oh boy, here we go. Hello. Yeah, I got an email. No, she was not. Yeah. Yeah. Now we got this out. We've got all day. Okay. So is 1/3 on our unit circle? And this is funny because we just had never mind, but we just had 1/3 as a cosine value on the last one, so very similar situation. But don't worry about it. What does this mean? Okay, you're always in quadrant 1 and inverse sine of positive ratios. Y is 1, R is 3, and then we just did this. 3 squared is 9, 1 squared is 1, 9 minus 1 is 8. Square root of 8 is 2 root 2. It literally was dealing with the same ratios or same side measures on a different triangle on the last question. Remember this. I never find this angle measure. But what I have now is cosine of 2 times this mystery angle measure. And all I have to do is use this triangle to fill in this formula then, right? Because I have the angle measure in question that I need. So which one do I want to use? Let's use my favorite. Let's use the easiest one. Let's use the sine one because sine is easier. So it's 1 minus 2 sine squared theta. Right, and that's 1 minus 2 right at the better way once we throw this fraction in. Sine is 1/3. So I avoided the radical this time. When you have choices but the cosine one, pick your easiest choice. That's 1/9 times 2 is 2/9. This is why we got the same answer as we got for one of the ratios on the last one. Very similar triangle, same sides, dealing with 1, 3, and 2 root 2. So we got that answer. Okay, so that's how you do that. Yep, I'm all good. Then I think we get to do a tangent one on this one. Same idea. What quadrant do I have to be in for this, though? Where does this have to be drawn? What's the rule say about inverse sine? It's got to be 4. Okay, it's not 3. Sorry, didn't do the sounds. What the heck just happened there? Okay, I hit the sidebar there. Negative 4/5, come on, that's 3. All right, so we get 3 for that. Okay, so just to look at it real quick, it's the same idea. This is tan of 2, and then this is theta, and then this is theta. So I just use theta as information because this becomes, remember, it's related to the sum rule. This is in case you forget the formula. Tan plus tan is 2 tan. So 2 tan theta over 1 minus tan tan means tan squared. Okay, so then we'll fumble. 2 tan is y over x, negative 4/3. And then I got it. 1 minus negative 4/3 squared. Okay, and then I'll zoom in on that. So let's get the top cleaned up. Negative 8/3. And then let's try to do some math all together here. Yeah, maybe not. Negative 4 squared is 16. 3 squared is 9. It's 1 minus that. Let's make this 9/9 again. And then we'll do a little divide flip. Divide turns into multiplication and flip. 9 minus 16 again is negative 7/9. What the heck just happened there? Okay, I'll make that a real fancy 9 now. All right, and then I could go ahead and multiply flip. I could cancel that 9 and that 3 right now, but it'll happen right now. Okay, this cancels to be 3. That cancels to be 1. Negative over negative is positive. So we're at 24/7, I believe. Everyone okay? I make any mistakes? I tend to do that at times. Okay, so again, dealing with tan is the worst because we don't like our fractions. All right, this one's a strange one. Look at this one. Find an expression for cosine of 4 theta as a 4th degree polynomial where it's in terms of cosine of theta. So this means, well, first of all, I think I know where I'm going on this. Okay, and I hope you understand what I start off with. Don't you agree that this is 2 times 2 theta? Say yes. Or, no, I like it because I have to leave this in terms of only cosine and it's got to be of theta. So that means I have to use my favorite, which I haven't used yet, and I said it's my favorite. This one, but this is still 2 theta. Okay, so I have to deal with that. You know what I'm going to do? I'm going to write this the right way now. I'm going to get rid of this and then put brackets here and write it the way what it really means. Because then this leaves me freedom to do the next thing, which is turn this into theta somehow. I got to get rid of that 2 theta and turn that into theta. And how would I do that? Do it again. 2 times bracket. This is 2 cosine squared. Now the argument's theta where I want it. Minus 1. And then minus a 1 out here. Wrong. Squared. Do not lose that. Good factors, say it. What? No one said anything. Good factors, good whats? I just like saying that because this is not factoring, but what do we have to do? Foil 2 brackets. I'm not going to put a bracket because I'm going to start foiling. I'm a good foiler. 2 cosine squared times 2 cosine squared is 4 cosine to the 4th. There's that 4th degree. Theta. And then 2 cosine squared times negative 1 twice is negative 4 cosine squared. Theta. And then negative 1 times negative 1 is 1. And then put that minus 1 on the outside. Okay, you should have that all written down over there, so you should understand where this came from. This is the brackets foiled. Then distributes, and then add. This becomes 8 cosine to the 4th. Wax on, say it. The point of these is just to use the formulas and try to give you goofy, different little questions to, just do stuff. I don't know what else to say about that, but that's why this question exists. So just employ the formulas and make a smart decision. I almost never use the cosine squared minus sine squared one because it requires two different trig functions. But sometimes you have to. Okay, and then where are we at? On to verify, and then we got one more. Okay, good. The last one is a little reverse analysis. Okay, and then it's the same structures. Understand what's going on. You got the same structures that we've been doing. It's just different formulas. So hopefully this doesn't end up being too bad. This is a tough question. Who looks more complicated, left or right? Left, but the right has a cosine 2x, which I just learned a new thing about it, so I might try something with that. So I think I'm going to work with the right. The next thing is, which cosine 2x should I use? Think about this for 10 seconds, looking at the left one. I was going to say 10 seconds, but some people already answered. Which one? The one that only has one in it. Say it out loud. Sine. So step number 1 equals right side 1 minus 2 sine. Look at it, already happens. What's 1 over sine, everyone? Okay. And look at the left side. But I got some people skipping steps. You got points off on your identities. You don't just you got to write this. You got to write 2 equals 1 over sine. You got to show that you know that this splits up into two separate things. Then maybe show this canceling. That's fine. So this cancels with this. And then just show me one more step that you know this is cosecant of x. It always ends with writing exactly something equals itself. Okay? All right. So we're done with that one, and then we only have one left. Is everyone okay so far? All righty then. Whew, so brisk in here right now. Hey, let's read this one. Cosine of 2 theta equals this. 2 theta is stuck there. Oh, then look at, they tell me something about theta, not 2 theta. What quadrant is that, by the way? 2. But then they asked me to find sine of theta, cosine of theta, and tangent of theta. And this is 2 theta. How do I do this? Make a choice. The worst choice would be the one with 2 variables. Cosine squared minus sine squared. I don't know what the best choice is. So I'm going to pick my favorite. 2 cosine squared theta minus 1. Now I got it to theta. Theta, theta, theta. Okay, so now I got it in the correct argument so I can answer the question. All I have to do is undo operations now. This is like equation solving, but not really. It is a little bit. Okay, but not really. So add 1. No, I'm not going to add 1. I'm going to add 13 thirds. So 13 sorry. All right, so that cancels. Then the next thing is I'm going to multiply by a half. So I'll write this real quick and get this done. This is 1/13. Multiply both sides by 1 over 2. 1 over 2. You're gone. And then I have cosine squared of theta equals 1 over 26. And then I square roots. Okay, now I can look. I see why they told me this. I got to choose when I square root between what's? Plus, anyone? Plus or minus. This is the square root of 1 over the square root of 26. Let's think about the square root of 26. That's 2 times 13. Nothing comes out. So 1 over root 26 is root 26 over 26. But you know what? I want to remember that was 1 over root 26 and I had to choose between plus and minus. What should I choose, by the way? Plus or minus? Minus. So there's one of my answers. I got you. There's cosine. But the reason I wanted to keep that 1 over 26 is because All right, 1 is wrong. -1. And then root 26. Oh, this is nice. What root 26 is the R? What's the root 26 squared? What's 1 squared? What's 26 minus 1? What's the square root of 25? That's easy. And it is positive because of the quadrant that they said. 5 over root 26 is 5 root 26 over 26. And tan is easy. Tan is y over, I almost did 1 over 5. It's -5 over 1, right? Y over, I want to check my notes and see. I want to make sure I put 5 over 1 in first hour. I'm getting a little nervous. Oh, thank the maker, if there is one in a public school. I don't want to offend anyone. Oh, there's my kids. All right, I'm done. Have a good day.